So hello everyone, welcome to this particular video. We'll be talking about Snowflake interview questions, very important. And if you're going for Snowflake data engineering interviews, at that point this particular video will help you so much of interview aspects I have said, and so much scenario questions are there, major questions that will definitely be asked to you whenever you are going for the interviews, because I am a senior data engineer working for I have an experience of more than around 5 years. It has been more than 5 years working as a data engineer, and I have been talking about and mentoring people from last 5 years only. And definitely this I have taken many interviews, many live interviews. I am a remote data engineer also, so I have those kind of live production experience also to guide you of the interview, how exactly you can set up the things and how exactly you can answer these things to get more offers and these things. And I am also a certified Databricks data engineer, professional data engineer. Definitely I can give you that particular thing. So let's talk about, as you can see on my screen, let's talk about top Snowflake data engineering questions that we'll be talking about. And we'll be talking about practical. I have my pen tablet in my hand. I'll be talking about everything very practical insights I'll be giving you. I'll be talking about real world SQL production ready things. I'll be giving you as answer you this, how exactly you can design the systems as a data engineer, how you can think, and those kind of things I'll be trying to give you. Definitely in one video it is not possible to give you all kind of aspects, but yes, I'll be trying the max to transfer my understanding of the things, and definitely you will be benefiting of it in the interviews. So definitely, who is this for? So suppose you are going for technical interviews, okay, technical Snowflake interviews, so you can understand deep about Snowflake production pipelines. You want to understand about enterprise workloads, how they are running, so that also you can understand from this, because not only interview questions, I'll be talking about the concepts also in the between. I'll be explaining it from a very scratch, so I'll be giving you that also. So let's start with the first question of Snowflake. And also if you want to practice about Snowflake, I have taken we already have a bootcamp end-to-end of this data engineering DataX Bootcamp. In that we have a module of Snowflake also. If you want to learn about Snowflake, definitely you can learn. Other than that, there are all kind of cloud, all kind of things we have already integrated, and definitely you can get all those kind of learnings, understanding of those things, how to set up these kind of code, how to set up these kind of repositories, all those things we have talked about. So that you will be getting in this particular bootcamp. Okay, we'll be talking about that also in going further. So let's talk about what is a difference between a database, a schema, and a warehouse. Whenever we talk about a database, schema, and the warehouse, and I'll be showcasing you practically also, so that's why I've opened Snowflake also. So understanding the fundamental separation of the architecture of the Snowflake. Okay, whenever we talk about database and schema, it is a logical organization layer where you load your table, views, data objects. They reside in your database and the schema. Database will be there, then your schema will be there, and in that schema only your all kind of views, tables, data objects, whatever are there, that will be loading. Other than that, what is namespace hierarchy will be there. 2-3 level namespace are there. First level will be of your database, then will be your schema, database.schema.table name. 3 level things will be there. Then your this thing, that is object organization, will be there, that we will be talking about. Next thing, warehouse is something that is in Snowflake we talk about warehouse as a compute engine. Okay, compute engines, resources, completely independent and flexible. And we talk about in Snowflake as Snowflake is a decoupled system. There is a separation between a storage and compute. There will be an external and you can also, that helps you to independently scale. You want to scale only, you want to increase only the storage, you can increase only the storage, because it is independent also. That is an advantage of using this cloud, it is a cloud native data warehouse. Definitely you can use that. Okay, it isolates your storage, processing power is separate, auto suspend capabilities are there. If we talk about, I want to showcase you that also. So this is the compute, here is the compute. Okay, these are the computes. You can create your computes also, different sizes of the, here it is X small, XS is there. There is, if you go to catalog, you can create your database explorer, you will go, you can see your databases, you can create your databases. If you go inside database, you can see schemas also. These are the schemas from a project that we talked about. Different kind of schemas you can create directly. You can see the databases also. That is the understanding of this thing. Okay, you can also start the trial version directly. I have taken a class on this also. You can understand about that. Next question is basically that is the separation that we talked about. This is not a question, it is just an addition to the first one. Single storage layer will be there, multiple compute options will be there. You can set up different kind of compute for different kind of task. For processing you need a different compute, for transformation you need a different compute. That is a best practice also. Okay, you should not use one compute for all the tasks, because the size of the compute also matters. Different sizes of the computes will be there, different types of things will be there. So independent scaling will be there. That is also one of the thing. Then real world setup, whenever we'll talk about data ingestion, BI workloads, these, see here only different kind of warehouses are there, or computes are there for different kind of tasks. For a dashboard we have different kind of this warehouse. For this thing we have a different kind of warehouse is a compute only, we have a different kind of warehouse. For this also we also have a different kind of ingestion warehouse. So that is how we separate our computes also. It's just a name, you can name give different type of names also, that just a name. Okay, so that is also important. Second question is handling duplicacy. Whenever you talk about duplicacy, like duplicate data, how you will handle duplicate coming data in whenever you are doing Snowflake ingestion, data is coming into the system, how you will handle that is there is a this is a very common question, very common scenario is there. First thing, same file can be reprocessed different time. That will help you to, that will eventually be loading duplicate kind of data. Duplicate events are running in the system, 2 times the pipelines are running. Network failure can happen, double writes can happen. Okay, CDC, change data streams can be like replaying the 2 times, it is not updated, replaying 2 times, and that eventually loads the different 2 types of data. So basically how you can solve this, you can use merge with the business keys. There will be business keys, you can use merge into directly. Merge into is very powerful. It is also called as upsert, in which you can set up if it is matching, then only update. If it is not matching, directly like just insert it. Okay, stream plus task you can use. You can, golden rule is you have to design idempotent pipeline which deterministic role and produces consistent result regardless of different. So definitely you can use all these 3 together also, and different one only merge also you can use if you want. If you know only merge I can use, and you can definitely merge we have been using in the production systems many times, and definitely it definitely helps in that. Okay, so merge based deduplication, this is called as merge into. Merge into is something that is where you can set up, it is a normal SQL command like merge into whatever table you have to give, and when matched you have to give some set of you have to update, and when not matched just insert. That is how the merge into works. Okay, you have to give whenever the rows are matching. This one, whenever it is matching, this key was already present, means just update these keys, these things. If it was not present, insert these things. Okay, that is how we have to like design these kind of things. That is how you have to think also. Merge into is very, very important. And as I talked about my DataX Bootcamp, end-to-end data engineering bootcamp, we have Python from scratch, data modeling from scratch, Hadoop, Snowflake, Spark, Apache Spark. Then we talk about PySpark. We have Pandas, we have SQL, we have Azure Databricks, we have Azure Data Factory, we have GCP, Google Cloud projects, proper live projects are there that we have used. And we also have data in like Gen AI, generative AI module also for data engineers. So definitely you will be an AI ready data engineer. To learn those things, definitely it helps you. Everything is job focused. Definitely all the links are in the description. Coupon code is also there. Any doubts you have, we also have a support number. Directly go there, ask your questions, and all things will be sorted. And you can also any problems in enrolling, anything you are happening. There are more than 450 students in our different batches in total. Definitely so many people have got success stories, so many people have got their offers, so many people switched from support background to data engineering background, non-data background from to data engineering background. Definitely you can also do it. It is suitable for all kind of backgrounds, okay? Because we talk about from the scratch. Next question is basically that is Snowflake streams, why pipelines miss data. Whenever we talk about Snowflake streams, okay, Snowflake stream is basically first thing, it gives you a functionality of CDC, change data capture. Whenever a data is getting changed, one stream you have set up And now if this particular table got changed, anything got inserted, anything got updated, anything got deleted, whatever change it is, on the target table, automatically a stream will be running and directly it will be applying that particular things to the target tables also. That is a functionality that tracks your insert, update, delete, all those kind of on the source table, and allowing the downstream things, because you will be setting downstream like tables also, or anything you will be setting so that it can eventually take all those things directly and load and affect on that tables also. That is how the stream works. Okay, next thing, common failure patterns will be there. Multiple job are reading the same stream consumption, that can conflict will be there, so that you have to plan the streams very well. Next thing, stream retention. Definitely you have to learn about streams also to understand this, that all things are there, and in Snowflake we have covered all those things definitely. Okay, production best practice is there. One stream, one consumer. Every time you are setting up a pipeline, one downstream should have only one stream job. You should not set up multiple streams to avoid coordination issues, should not be there, conflict should not be there, and robust orchestration should be there. So definitely set up like this. This is the rule. One stream, one consumer. Okay, that is how you have to set up the thing. Next question is stream monitoring. Whenever, suppose you are running a stream, you have set up a stream like this, you can monitor. Select star from my stream. Whatever streams will be there, it will be showcasing you all those kind of streams. Okay. Next step is basically how to validate it. Directly you can validate it. You can go and do like this, system dollar whatever stream has data, and whatever stream is there, name of the stream here you will give. So it will give you all those kind of things. Okay. That is how you talk about or validate your stream. Production tip is basically, that is always validate stream step before consuming and avoiding processing the empty batches, because many times what happens, people set up the stream and they think backfill of the data, previous historical load will be also done. No, historical load will be not done. You have to do one time historical load. After that, whatever changes were there in the stream, then only on the target table insert, update, delete is happening, then only on the downstream things, then only eventually it will be applied. That is how you have to think. Okay. Fourth point is basically stream plus task plus versus merge into. Like there will be comparison. Why a task and stream? Task is something you can schedule it. Like I want to run something every 5 minutes. You can create a task directly in the Snowflake and directly it will run. It can be a merge statement. It can be an update statement. It can be a delete statement. It can be a CT. It can be a select statement. Anything. It can be a create table statement. Anything you can set up in the task. Okay, so what is the difference between these two? So merge batches, whenever you're talking about merge into, okay, merge into is predictable, cost structure will be there, easier debugging, replay will be there, sufficient for most business requirement. We can use multiple times merge into. Stream and task is also a very good approach. It is event driven architecture. It enables near real-time approaches, near real-time availability of the systems, and it provides you automatic change in the direction because it is a stream. Whatever changes are happening in the source, directly it will be appended to the target also, because a watcher is there that is watching everything. Okay, so that can happen. So that is a near real-time system. So we talk about sub-minute latency is possible, automatic change tracking is there, higher. So it depends on your use case what you have to use. In the interview inside, stream plus task are event driven things are there, and merge into is schedule driven. Suppose you have to use only my limitation is I want to run only merge into my product, like business has said I have to use only merge into. So merge into you have to schedule. Okay, merge को schedule करना पड़ेगा. Then only you will be getting on a frequent basis that merge into. Directly it cannot run, right? But stream plus task, what it can do on a schedule basis, every 5 minutes and 10 minutes, every day, every daily, every month, every year, whatever schedule you want to apply, you can apply. Okay, that is an advantage. Whatever query optimization, let's talk about without indexes. What is a query this thing? Okay, let's talk about the query this thing. Okay. ठीक है, गलती से just okay. So query optimization. Whenever we talk about query optimization is one of the very key skill set, very important whenever you are going for the data engineering interviews. Optimizations are very important. This question will definitely come. Why, if indexes are not there in warehouses, without indexes, how you handle the things? The use cases are different. Okay, let's talk about that. Micro partition pruning is there. That is very important approach. It will divide whatever data you will write on the tables. It will be writing it into micro batches. Micro partition pruning is there. Warehouse sizing you can control. You can control your query rewrite. You should not use select star everywhere. You should filter out the things, where clause and everything, so that intermediate results are also smaller and eventually your query is faster. Strategic clustering should be there. That is how cluster by also you should not use every time. It is not beneficial every time. It should be strategic when you have to use cluster by, when you have to cluster the data. That is also so important. Okay, practical performance debugging is there. You should use query profiling. In query profile, it shows you everything, where it is taking a longer time, where it is taking a shorter time, which transformation is taking very long time, how many bytes were scanned, full table scan is happening, all those kind, how many partition pruning is there, what is the spillage, if out of memory is happening, what is happening, any Cartesian product cross join you have not used. Cross join is the very costly join. You have not using cross join. Clustering is something that it sorts the data in the same partition. So cluster you can use definitely. Okay, so these are the some of the very important aspects of understanding this thing also, and understanding how exactly the things will go. Okay, so that is also very important. So understanding micro partition, whenever you run or write a query, automatic compressions are there. Automatically Snowflake creates 50 to 500 GB compressed. It is a functionality of Snowflake. Don't need to worry about that thing. Snowflake automatically compresses your storage block containing columnar data, because it works on data warehouse. This data warehouse, Snowflake data warehouse, BigQuery data warehouse, it works on columnar storage. So it compresses your data, then only writes it. So it becomes, first step only becomes a very fast this thing. Metadata intelligent it is. Each partition, whatever stores your min and max value, null count, distinct counts, enabling the query pruning, everything without scanning whole data. You have to not scan whole data. The data warehouses, the cloud data warehouses are eventually very intelligent to do those kind of thing. Query pruning you have to do. Like if you are using select star at multiple places, don't use select star. Limit your result. Like apply where clause, apply limits. Okay, that is how you have to design the things. That is the design principle also. Very important to understand. Next thing is time travel versus the fail safe. Time travel is something, suppose you have, like by mistake you deleted some kind of data, or you dropped a table, or you truncated a table. By mistake it happened. You can come back in the time and directly you can get the data. That is, historical data can be loaded back. Retention is 0 to 90 days, and definitely you can configure it. You can keep it 7 days, you can keep it 30 days, 45 days. It is configured. Okay? But till 90 days only you can do that. It is configurable till 90 days. Then immediate access via the SQL. Directly you can use SQL, and directly it is managed, and restoration is done by the developer. It is developer friendly. Fail safe is a disaster recovery safety net. Snowflake managed data protection for this, like by mistake any failure happened. Okay, so not instantly accessible. It is not it requires the contact, like Snowflake support you have to contact, and from there like additional 7 days protection is there. Then non-queryable users, directly you cannot query on this. Fail safe is something like that. So it is better to use time travel every time, because it is a developer friendly also. Directly you can get those kind of results. So this is about the time travel and like fail safe. Very important to understand about. And in the production strategy, we definitely use the for recovery of any bad delete happen, any incorrect update happened, any fail safe is an insurance definitely. But for a developer this thing, because fail safe will take you time also. Support pe jaake you have to raise a ticket, those all kind of hustles you have to do. But time travel is right away you can query on it. It is SQL friendly. Directly via SQL you can do that. You can create a table, you can do all those kind of recovery patterns are there like this. You can select it at which timestamp you want to see the data. Whatever timestamp was there, at that timestamp it will show you that data. Other than that, you can also restore the entire table. You want to create that table directly, you want to restore it somewhere else. So that can be also done. You deleted anything by mistake, that can be also like recovered. Truncated any table, dropped any table, whatever thing you have done, you can like set up those kind of time travel things and directly use it. So loading and flattening of the file. Whenever you are talking about nested file, API kind of data, we talk about variant. variant type of data. That is in the Snowflake, it is Snowflake GCP, it is like available. That is, it is a data type, same like string, varchar. It is a data type where you can directly work with JSON handling, JSON kind of data you can work. Bronze layer, you can directly store it as a like JSON, and directly after that you can flatten the files. We have already done these kind of projects in our Snowflake module project. Definitely we have done that. Definitely if you want to understand, if you have not if you are not enrolled, you want to enroll, learn about that thing in very much detail about data engineering, that is the best resource to do, and it is very affordable also. Links are there in the description. Use that and get into that. So in the silver layer you do all those kind of typecasting and all, JSON flattening and all, and in the golden layer carefully fully flattened data will be consumed by the consumption layer. Okay, and in the gold layer we call it as consumption layer, because on the gold layer only your like Power BI reports, your reporting, all those kind of business aspects will be done. So flattening functions are there in action, like lateral flatten. Lateral flatten is used like this, directly used like this, and directly if the payload is the column, and directly you want to fetch the orders column. Okay, and how you will fetch? Like this, f.value.order id you will fetch, amount you will fetch, created at it will fetch, like this you fetch the things. Okay, so it is a key technique, lateral this thing, what we call it a lateral flatten. Okay, so safe incremental pipeline. In interviews, definitely incremental pipelines will be asked too much. Snowflake doesn't guarantee you exactly, because many times what will happen, late arriving data. This is the big. Suppose you got a data, you get everyday data at 10 a.m. But today you got only 50% of data at 10 a.m. and rest you are getting at 2 p.m. So how you will handle rest 50% of the data if the late arrival things are of the that is called as incremental, safe incremental pipeline. Incremental pipelines you have to set up. If you don't set up, eventually your data will grow and out of memory errors can come in. So we talk about idempotent load, we talk about deterministic keys will be there, merge operations you will use and directly merge it. Okay, next thing will be audit tracking, directly till where it was loaded, now from where to where you have to load. Stream isolation, we already talked about stream and task. Okay, that is also very important. These kind of techniques you can use to make your pipeline safe, incremental safe pipeline. Okay, and definitely if you want to get enrolled, in the links are in there in the description. Use it, coupon code is also there, very much affordable. From the scratch you will learn the things, directly go and take the advantage of it. Next thing we were talking about the production pipeline, production design of the pipeline. Whenever we talk about, first one will be the stage ingestion, we have used these kind of techniques. Next thing, audit record, whatever records you have got, whether it is fine or not in the bronze layer, you have to merge the transformation. In the merge transformation you have to use in your silver layer. In the silver you will be doing those kind of thing. Next thing will be your status update you will be doing. Okay, very important to understand. Status updation you will be doing. At last, whether it is success, failure, all those kind of in their metadata tables that you will be creating, there only you will be loading those kind of things. So this is very important to understand also and to get those kind of things. Okay, next thing is your, that is 10th question, that is your permanent versus transient versus temporary. What are these tables? There are different kind of tables, right? Permanent tables are there, transient tables are there. So permanent table is something that is, it is a full protection table, it is a permanent table, and time travels can happen, fail safes are there, business critical data is stored there, high storage cost definitely it will be there, 90 days of travel time travel you can do on this. So majorly we use on golden layer, customer layer, or financial records, whatever you have to store, that all things you can store it here. Next thing is your transient tables. Transient tables are basically where you can do only the time travel, like time travel things you can do. It fail safe will not be there, cost savings it will give you. If you have directly you can create time transient table and directly use these kind of things. Then rebuildable data will be there, lower storage call will be there, 1 day of maximum time travel you can do, maximum. In the staging layer, in the intermediate, because staging layer you will not require permanently. Okay, you can require a staging layer for say for 1 hour, 2 hour, 3 hour, 1 day, because staging layer is something where your data is landing and from there you are fetching the data and getting it to your system main table. Okay, bronze table or something like that. So bronze layer also you can make it via the transient table. So that is how. Temporary table is something that is session scope. like you cannot maximum you can do 1 day time travel, lowest cost it is. Debug and testing you can do, or it is auto dropped whenever your warehouse got suspended or your session got refreshed, at that time only it will be dropped, auto dropped it is. So no need to worry about that thing, it will be storing any kind of memory. No, directly it will be dropped. That are the difference between three kind of things. So this is how you have to figure out these things. And design thinking, production safety, every time whenever you, I mean any kind of, in the previous video also whenever I was creating that, I told you in previous videos also, whenever you are talking about any kind of answer, scalability you have to think in the mind. You have to talk about how exactly, whenever today you are getting 50 GB of data and 5 users are working today. So if the system grows and 100 terabytes of data is coming in, 100 users came in, so how that system can handle it, that kind of thinking you have to have. So Snowflake is very, very important on the test design, and not just the memory, like you are not just memorizing the like syntax of it. So this was all about it. If you want to get enrolled into DataX Bootcamp, you want to learn about data engineering from the scratch, or you want to learn about data engineering, you are stuck into any kind of job, production job, any kind of support job, any kind of non-tech job, any kind of things, non-data jobs and non-data engineering job, you want to get into a data engineering job, this is the bootcamp for you. You will be getting all those kind of things. So many people have already got their success stories from there, and this was it. All the links, coupon code, things are there in the description. Use that, take that advantage of it. Jai Hind, Vande Mataram, bye bye.